which decelerate, of course, the jet. You can also see that the Mach number here, the scale, the higher Mach number is 5.25, but that's correct if, for example, now I'll plot the, let's see, in color map, instead of using the auto range, let's plot it, for example, let's set the minimum to 0.5. So then you can see where that 0.525 is. So there is like a small region here, which is accelerated a little bit more than, let's say, the free stream jet. So when we say in our the website, we were told that the Mach number over here of the jet, so in this section on the axis, should be close to 0.51. We should check that. So we can, for example, plot so we can create an XY plot. So this is on the x-axis, so we have x, the direction, and we select the velocity Mach number on the axis. So we can plot this value over here. So this should be around 5.1. Of course, if you want to be sure of that, you can write the file or even change the range. So I'll go to axis, and then for my y-axis, instead of auto range, I can select the minimum, let's say 0.5, and maximum 0.52. Apply, and you can see that at x equal to 0, we are close to 5.12, which is very close to 5.1, so we are happy with that. So we can go back to auto range and stay. So this ensures that our solution is correct, or at least we get the correct Mach number in that section. So then you can see also the Mach number distribution. So there is a first region. So the fluid is, the air is accelerated. It reached at the throat a Mach number of 0.51. Then it stays constant, so it's not affected by the non-moving air. But then at some point the velocity is decreasing because of the shear stresses of the air. Okay, then we can move on, and we can make the request of the homework, which are to plot those quantities. So basically, velocity components, turbulence kinetic energy, and U prime V prime. So the Reynolds stress, not on the diagonal of the Reynolds stress tensor, at different x over the jet. Now, as I said, you can find in Moodle a SCM file, which you can import or load in Fluent going through user defined. Then here you have the field function, so you can create new custom variables, which I'm going to select. And instead of creating new custom functions, you can go in manage, where you can actually load the SCM file that is available in Moodle. I put it in the folder where I have my mesh file, so in the working folder of Fluent, and you can just load that file. If you do that, you can see that we'll have all the variables that we need to plot. So there is ujet. Ujet actually is depending on the simulation. So this is the velocity at this point over here of the axis. So where our Mach number is approximately 0.51. Of course, if you have a Mach number of 0.51, also the velocity is exactly the same as I obtained. So here I got a velocity of 171.7 meters per second. Of course, you can check that you get the same results for your jet. So for example, I'm going back to my XY plot. And instead of plotting the Mach number, I can plot the velocity magnitude on the axis. Okay, and then here you can either write a file to get the velocity magnitude, or we can again go through axis. Instead of using the auto range, we can set the minimum and maximum range of the velocity. So we can set, for example, 171.5 as minimum, 171, and 171.5 as maximum one. Okay, this is actually higher. Okay, so we are approximately a little bit higher than that. Let's see. Not really. So that's 171.9 approximately, 80 something. I would still go for the 171.7. This is good enough for the ujet. Or if you want to be very correct, you can change that so you can create a new custom field variable. But this is enough. Correct. Then we have the jet.
What did you plot before?
Before, I was plotting the velocity magnitude on the axis to calculate, or let's say to visualize the velocity of the jet at x equal to 0. Or close to 0, let's say the maximum velocity here.
But I couldn't get this kind of.
I was changing also the ranges, because
You were
by
changing the range of y-axis or x-axis?
yes, the range of y-axis. So if you go to axis, you select y, then instead of auto ranges, you can set the minimum and maximum so that you can find it. Then we come back to auto range, and this will be the velocity on the axis.
Sorry, what was the minimum and maximum value?
I was setting 171, 172
Okay.
to kind of find two bounding values that are containing the velocity of the jet. But in the SCM file, so the expression file, is set to 171.7, which you can use, and the results will not be changing that much, so that basically 0.15, 0.2 over 171, so it's not very important. Then the second field function is the jet. So that depends, of course. We have that our radius is 5.4 millimeters. So that's going to be 50.8 millimeters. Of course, this is converted. And then I also created field functions for u over u jet. So this is u is the velocity component in the axial direction over u jet. Then there is v over u jet, so the radial velocity over u jet. K over u jet to the power of 2, so the turbulent kinetic energy over u jet to the power of 2. Then here you can find u prime v prime, so the Reynolds stress. This is exactly the same equation that we have seen last week. So the minus the ratio between the turbulent viscosity over density times the derivatives of, let's say, du over dy plus dv over dx.
I have a question.
Yeah.
So this, once we type this equation, can it be edited anymore? Or it can?
You should recreate them.
Yeah.
You can't, yeah, that is not very nice, let's say, with fluent that you can't actually put your hands on it. You need always to put them.
Okay, thank you.
Actually, you could edit them, but it's not very easy because in this expression jet, this is basically a text file. So if you know what you are doing, basically you can recreate them.
So this way we couldn't do it for the exercise.
Yes,
before.
yes.
Oh,
Basically,
okay.
you can also load that in any case of Fluent. So that's as long as you have those variables.
Okay.
So if Fluent doesn't find the variables, then you give some kind of error.
Thank you so much. Okay.
Probably if you ask ChatGPT also, then it will throw out something like that, and you can then start from there. Yep. Okay.
We need to make the lines first then.
Yeah.
Then we close all this.
No, they are already set. So once you load them, they are there.
It's all there. That's not function.
Yeah, yeah. Then you can put them before.
So we need to make the lines first.
Yep. Yep. Which is there?